Alrighty then. So let's do this. Okay. So we are going to start Unit 4. I haven't full on mapped out when we will test on Unit 4. We're started early this school year, so I would normally say we'll test on Unit 4 the last day or the second to last day before winter break. But I can't say that now because we're all kinds of discombobulated, and now Thanksgiving's coming into play and all this fun stuff. So because of that, I haven't quite mapped it up yet. I'll let you know. I'll update our board tomorrow. I'll update it today, but then you'll see it on Wednesday. Okay. Unit 4 is going to deal with rational functions. Okay, and I'll be honest with you. We're going to go through some graph paper in this unit because we're going to be graphing rational functions. Okay, right? And so we'll get you all the fun steps and all of the things that you need to do, and so that it makes it easier than easy.
Sorry.
I know, that's what I'm saying. So you decided not to get it a little chalky? Yeah, that's what I hear. Okay? Alright? So, let's start with the basics. Okay? Last unit, we learned all about a rational number. Okay? Does anybody remember what our definition of a rational number was? Any number that can be put into a fraction. Yep, so it's any number that can be written in the form of a fraction. So that's a rational number. Numbers that can be written as fractions. So let's use that logic now to figure out what a rational function is going to be. What do you think a rational function will be if a rational number is a number that can be written in the form of a fraction? Rational number that can be written in the form of a fraction. Rational function would be a function that has functions within it in the form of a fraction. Okay? So a rational function is a function that has a fraction. The numerator of the fraction is its own function. The denominator of the fraction is its own different function. Okay? So P of x and Q of x are polynomials, but Q of x is not just 0. The 0 is a function, but it's not 0. You can't divide it. Now, we're going to drop a D word, okay? Because it's going to be important to us. Okay? The domain of a rational function includes all real numbers except x values that make the denominator equal 0. Okay? So what I mean by that is the domain will be all real numbers. Now, instead of having to write out all real numbers, you can just write the fancy R. The fancy double vertical R is the symbol for all real numbers. Okay? So if I had a function, let's just say the domain of that function would be any real number except the number or numbers that make the denominator equal to 0. So what you would have to do then is you would have to look at the denominator and you would have to set it equal to 0 and solve it. Which in this case you would get then so those two numbers would be excluded from the domain. Because if I plug in 3, I get 0 in the denominator. I can't do 5 divided by 0. If I plug in -2, I get 0 divided by 0. And I still can't even do that. You can't divide by 0. Okay? So the domain of this function, if we were finding it, would be all real numbers, but x cannot be -2 or +3. That's how we would write that. So what happens at those spots? So strange things happen there. Okay? So let's use an even easier function as our example now. Okay? So f of x equals 7 divided by x minus 2. Okay? So I would set my denominator, x minus 2, I would set that equal to 0. I would add 2 to both sides, and that would give me x equals +2. So my domain here would be all real numbers, but x cannot equal 2. Because if I plug 2 back into my function, I divide by 0. And I used to be able to ask Siri. And Siri would say something along the lines of Cookie Monster has 0 friends and 0 cookies. He has 0 cookies and he divides it amongst 0 friends. And then you're sad because you don't have any friends. Nobody has cookies. It's something goofy like that. He doesn't do it anymore. He's disappointed that they got rid of that one. Okay? So we have that. So now what happens there is at these points right here, we get something called vertical asymptotes. Okay? Because the function cannot exist there. So we block out that whole section of the graph. So whatever that number is, nothing can exist there. So we block it totally out. Okay? And so we put a vertical asymptote there. Now, we are going to be creating 8 steps to graphing a rational function. So what I would like you to do now is I would like you to get out a total blank sheet, fresh page of paper, okay? Take it out of your notebook if it's in your notebook. Take it out of your loose leaf binder if it's in your loose leaf binder. But this is going to be the start of your semester 1 note sheet. So remove fringes, yep, get rid of it, make it look nice and pretty, all that fun stuff. Okay? Up in the upper corner, I don't care, left or right, put your name. You just need your name, just in case you leave it in the room somewhere, we know who to get it back to. Put your name up in one of the corners. Okay? Now, the front side of this note sheet is going to be mine. Okay? So I'm going to, well, I shouldn't say I. We are going to fill in the front side. You get to put whatever you want on the back side for the final. Okay? But the front side is mine. Okay? So save that front side for the 8 steps that we're going to have going on here now. Okay? So very important. You will also be able to get to use this note sheet on any and all things here on out for the rest of the semester. Okay? So you can use it on formatives, you can use it on quizzes, you can use it on the test, all that fun stuff. Whatever you want from here on out, you'll get to use your note sheet. Okay? So let's start with this. So you don't have to write this part down, but this is on your extra sheet now, not in your notes. You don't. If you want to put the steps of graphing a rational function at the top, that's fine. Okay? But the first thing that you're going to do then is you're going to write down what a rational function is. So you're going to write down the general rational function that I have written right there. Okay? So f of x equals p of x divided by q of x, where p of x is a times x to the n power, okay, plus whatever comes after it. You just really need to know the a and the x to the n over b times x to the m power. Okay? Then you're going to save room for step 0. Okay? So you can put step 0 and then skip 2 lines so that you have some space. Okay? So you're going to save space for step 0. We'll actually get to step 0 last. Okay? It's weird that we do the last thing first, but that's just how we roll on that one, because we don't always do step 0. That's one. Okay? Then we're going to go to step number 1. Step number 1 is going to say the very first thing that you are going to do with when you go to graph on every single one is you are going to find the domain and any vertical asymptotes. How are we going to find the domain and any vertical asymptotes? Well, we are going to set our denominator equal to 0 and solve. So, back in our notes now, not on our supplemental sheet, our extra sheet, it says find the domain and any vertical asymptote or asymptotes for this function. Okay. Well, how do I find the domain of this function? What's my denominator? The bottom part is my denominator. So I would say 2x minus 5 equal to 0. What would we do to go about solving that? Add 5. X equals 5. Divide by 2. X equals 5 halves. 5 halves times 2 is 5. Minus 5 is 0. Check out. So what is my domain? What would my domain be? All real numbers. So we would write it as all real numbers, x cannot be 5 halves. So what happens at x equals 5 halves? That's our vertical asymptote. And so we're going to label that VA. We're going to have VAs, HAs, and SAs in this unit. Okay? But we're going to always start with just then a VA. So notice, what you solved for, that's your vertical asymptotes then. Okay? So if I were to go way back to here, to here, to here, x equals 3 and x equals -2 would be my vertical asymptotes. My domain would look like that, but those then, the next step, my vertical asymptotes would be x equals 3 and x equals -2. Okay. Love it. Good stuff. Okay. So now, before we get into some more awesomeness, okay, let's take a pause and let's talk some logic. This is where I love this day because it's all about thinking. Okay? It's all about what we want to think. Okay? Okay? So let's talk about some fractions here. If I have a really big number and I divide it by a really small number, what is the resulting value going to be?
Medium.
Medium?
I mean, it kind of depends how big the big number is, how small the small number is.
Well, let's make the big number super ginormous huge, and let's make the small number teeny, 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 tiny. Barely any change?
Well, there's going to be like.
So, like, let's say 100. Okay? You divide 100 by 100. What do you get? 1, right? Okay? So now let's make it smaller. You divide 100 by 50. 2, right? Okay? You divide 100 by 10. 10. You divide 100 by 5. You divide 100 by 1. 100. You divide 100 by a half. 200. You divide 100 by 0.1. 1,000, right? Okay, see how that's going up? Okay, getting bigger and bigger and bigger. So the smaller your number gets, let's say this goes to 0, what happens to the value of your function, right, of your fraction? It's getting bigger and bigger and bigger, right? It's getting so huge that it's really going to go to what? Because if we divide by 0.01, now I'm at 10,000. If I divide by 0.001, now I'm at 100,000. Right? Oh, you already got it. Okay. That's good because I'm not handing them out yet. Okay? So what does this huge number go to? It goes to a positive infinity. Yep. Okay? It's going to go to positive infinity. Now, line 4. There is some good stuff. So pick up the video at 20 minutes. Okay? Next. Let's reverse that. Let's say we take some small number and now we divide it by a big, oops, I shouldn't say big number, I shouldn't say huge. Let's say divide it by a big number. Now what's going to happen? Negative? Because let's keep it all positive. Teeny tiny. What's it going to get closer and closer and closer to? 0, but it's never going to get there, right? But it's going to get closer and closer and closer to 0. Okay? So the bigger that this one gets, the closer we get to 0. The smaller that number gets in the first one, the more we get to infinity. Okay? Now, here's some more logic for you. This is really super high level math stuff here now. If I put a plus sign in my exponent spot, okay? If I am dealing with an x value, that means I am approaching from the right. I'm getting closer and closer and closer to that value on the right side, on the positive side of that number. If I'm dealing with a y value, I would be approaching it from the top or from above. So if it's a y value that I'm getting closer and closer to, I'm getting closer and closer to it from above. And coming down on 3, but I'm not going to cross it. Or I'm coming towards 3 from the right. If we put a negative sign up there, now with an x value, I am approaching it from the left. My y value, I'm approaching it from below. Okay? Because we're going to talk logic now for the next 25 minutes. So we're going to start out with the easiest of easy functions. 1 over x. Okay? If you're down at the bottom of a page, if you're less than half of a page, you get less than half of a page, start afresh. Because there's a lot of things going on in these problems. Okay? So first off, we have to find the domain. Second thing we got to do is we got to find the vertical asymptotes. Third thing we've got to do is we've got to describe asymptote behavior which I'll talk to you about here in a minute. And the fourth thing that we've got to do is we've got to give the end behavior of this graph. Okay? Just when you thought we were done with end behavior, I come back and I bring it back more. Okay? So let's start with number one, find the domain. How do I go about, from our supplemental note sheet that we just started, how do I go about finding the domain of a rational function? Ray, go. Set the denominator equal to 0. So in this particular case, it would be x equals 0, correct? And then I should solve it. Did that already, right? Okay, all right. So my first answer is going to be the domain of my function is all real numbers, but what? X cannot equal 0. Which means the second answer to this problem, what is my vertical asymptote? X equals 0 is my vertical asymptote. Okay? With me so far? Okay? So now what we have to do is we have this point. We've got this number, and it's called 0. Asymptotal behavior is what the function is doing on either side of that vertical asymptote. Okay? Because I can't cross over a vertical asymptote. And I can't do it because the function doesn't exist there because I would divide by 0. So I can't cross it. Okay? So as I get closer and closer and closer to 0 from the left side, okay? So that would read as x approaches 0 from the left. That's what we're talking here. You can't just say approaches 0 because it's going to be different on either side. So as I get closer and closer to 0, my numbers here, as I plug them in to this function right there, my numbers are getting smaller and smaller and smaller and smaller, which means my fraction is getting bigger and bigger and bigger and bigger, but it's a positive, right? 1 is positive. What's my denominator? I'm approaching 0 from the left. It's negative. So a positive divided by a negative is logic. All logic is negative, right? Okay. So my function would approach negative infinity. Because my function is getting bigger and bigger and bigger, it's just getting bigger and bigger and bigger negative. Okay? Because in end behavior, we talked about x going to infinity. We'll get there. We'll get there. I promise, because it's number 4. Okay? Okay? Now, I've got to come in from the right side. So now, as I approach x, or excuse me, as I approach 0 from the right side, what is happening to my function? My numbers, my x values are getting smaller and smaller and smaller and smaller, which means when I plug them into that function, what happens to the value of that fraction? No. So as I put smaller and smaller and smaller numbers in for x, it gets bigger and bigger and bigger and bigger, right? Okay, but now I'm on the positive side, right? So that means it's going to go to positive infinity. So my function here is going to positive infinity. Take a moment to let that sink in. All good on that? Okay. Now we've got end behavior. This would be as x approaches positive infinity, what's my function doing? And as x approaches negative infinity, what's my function doing? Okay? So now my x value that I plug into the function, x is getting huge. So when I plug that into my function, now I've got positive 1 divided by a number that's getting bigger and bigger and bigger and bigger. The value of my function is going to do what? Get smaller and smaller and smaller. So it's going to keep approaching what? 0, right? Okay. Now, is it going to approach 0 from above or from below? Because what if I put in positive numbers, positive 1 divided by positive numbers are positive. So it's going to approach 0 from above. Now, x is negative huge. And I put it into there. What's it going to be approaching? X is getting bigger and bigger and bigger. So the value of my function is getting smaller and smaller and smaller from the bottom, because now it's a positive 1 divided by a negative number. So it's going to approach 0 from the bottom. So let's take a moment and let's go back to this one. So my asymptotal behavior would be as x approaches 5/2 from the right, and as x approaches 5/2 from the left. Right? Or I should say correct. Okay? So I'm looking at five halves. Approaching it from the right. So what's that? 2.5? 2.5 is 5/2. Okay? So give me a number super duper close to 2.5, but on the right side. 2.6, great one. Okay? So if I put 2.6 back into my function, right there, 2 times 2.6. 5.2. 5.2 minus 5. 0.2. 1 divided by positive 0.2. 5, right? 5? Okay. Is that positive or is that negative? That's positive. And the closer and closer we get to that, the bigger and bigger that number is going to get. So this is going to go to positive infinity. Left side. Give me a number on the left side of positive 2.5. 2.4. 2.4 times 2. 4.8 minus 5. Negative 0.2, right? Okay. Positive 1 divided by negative 0.2. Negative 5. So what's this one going to go to? Negative infinity. End behavior now. As x goes to positive infinity, where's my function going? And as x goes to negative infinity, where's my function going? Okay? So now I'm going to put in a positive huge number. Let's say 1,000. Okay? 2 times 1,000. 2,000 minus 5. 1995, right? Great year. Okay? All right? 1 divided by 1995. Really, really small, right? Positive or negative? Positive. So this is going to go to 0 from above. Put in a negative number. Negative 1,000. 2 times negative 1,000. Negative 2,000 minus 5. Negative 2005. We'll go. Okay? Alright? I'm joking. I got married in 2005. Average. Okay? 1 divided by negative 2005. A negative number, but really, really small, right? So that would approach 0 from below.
Can I use the restroom?
Why not? I mean, I'm just wrapping up the whole lesson here. I mean, it's not like this is important at all for the next 2 months.
I'm sorry, I want you to go.
That's a you thing, not a me thing. Yep. With me? Okay? Alright? So, you have to do that on all of your problems right now. It'll get easier for you on Thursday. Because on Thursday, we'll start graphing. And once we see the graph, then it's just literally reading the graph. You'll see, oh, as I come from the right, it's going up. As I come from the left, it's going down. Right now, I'm giving you a way to check your graph on Thursday. Okay? Okay? Because that's the only way you can do that, is checking it. Okay? We have a homework assignment this week. It's blue. There's only 4 problems on it. And as of right now, you can only do 2.